Okay, looks like we're recording. Go to present mode. Alright, get right into it. So, we'll be talking about the Piper Seminole fuel system today, and my name is Aaron Miller. So, game plan, we'll go over a general overview of the system, and then after that we'll take a little in-depth look at how the fuel flows through the system. And then finally we'll take a look at a couple causes of trouble in fuel injected systems, specifically related to the Piper Seminole. So system overview. The system is fuel injected, meaning the fuel is mixed with air right before it gets to the cylinder. This is more of an engine operation topic, so I'm not going to go into too much detail right now, but just know that it's not carbureted like the Cessnas we have at Gateway. Alright, so we have two fuel tanks. We have one in each nacelle. So as you can see right here on this diagram, in red, these are the nacelles, one located on each wing. Each nacelle is a 55-gallon tank, and one of those gallons in each nacelle is unusable, which leaves us with 108 total usable gallons of fuel. So each tank is vented to allow for expansion, and then each tank also has a scupper drain as well. So when these tanks are getting filled up, it's a possibility that either you or the lineman, whoever's filling it up, overfills the tank, and it kind of spills out onto the like upper part of the fuel tank there. And if there's no scupper drain there to let that fuel drain out of the system, it would just sit on top of the fuel tank for the flight, which would be messy. And so that's each tank has that scupper drain to whisk away any of that fuel if there's overfill. Okay. So we have two different fuel pumps. We've got engine-driven and electric fuel pumps. To determine the quality of or the quantity of the fuel in the system, we have fuel quantity and flow rate indications on the MFD and the EIS, as well as on the engine page. So the EIS, that would be on the MFD. The left-hand side of the MFD always is showing certain engine parameters, and fuel flow and fuel gallons used and fuel quantity is always on that left side of the MFD page. But if you go into the engine page on the MFD, you can get a little bit more detail. So that's one way to determine how much fuel you have. And the other way, and the more reliable way, is just to use the fuel dipstick. So how you use that is you take this the dipstick, and I'm sure we've all done this as kids. You take a straw, put it in water, put your thumb over the end of it, pull it out, and you have, a certain amount of liquid in there. It's the same concept with the fuel dipstick. You put the dipstick in, put your finger over the top of it, pull it out, and then it's got hash marks at 20, 30, 40, and 50 gallon marks, and that way you can see how much fuel you have in the tank. So if you have anything less than 20 gallons, it's not going to show up on the dipstick. Okay? Alright. Inside the cabin, we have our fuel management controls right here. So we have our fuel selectors, one for the left engine and one for the right engine. We have on, off, and crossfeed. Okay. We also have fuel drains, one for each engine. These are located by the rear baggage door, so right under that door. If you open up that door, you'll see the fuel drains. To drain the fuel, you just need to depress the inner circle of that fuel drain, one for each engine, and then the fluid will come out, and you'll be able to check it for water, debris, things of that sort. Okay, we talked about that. Let's talk about cross-feeding for a second. So like we said with the system overview and the fuel management controls, there is the option to crossfeed. So what does that mean? In the crossfeed position, the engine is getting fuel from the opposite fuel tank. So for example, if we were to place the left selector in the crossfeed position, that means that the left engine will be getting fuel from the right tank. So we can see that here. The left engine is getting fuel from the right tank, and that's when we have a crossfeed scenario. A couple things to keep in mind when we are crossfeeding is when we're operating with a single engine and it becomes necessary to crossfeed, we need to make sure we turn the fuel selector for the inoperative engine to the off position. Another thing to keep in mind, we should never operate with both selectors in the crossfeed position except during the before taxi checklist, which brings up a good point. So in the before taxi checklist, it calls for us to bring both fuel selectors into the crossfeed position and leave them there for 30 seconds just to make sure that the crossfeed function is working on both engines should we need it down the road during the flight. So we're only supposed to do that for 30 seconds, and then we switch it back to both. Something that I've been told at least happens to some pilots is, they'll switch those to crossfeed. What's up, bud? They'll switch those to crossfeed, and then, in their head they're thinking, okay, in 30 seconds I'm going to go back and put those back to both, and they start working through the rest of that checklist, all the while forgetting that those are on crossfeed, and they wind up leaving the plane in a crossfeed situation. You could potentially even leave it that way for the whole duration of the flight if you neglected to look at it in the before takeoff checklist. So a good practice, good practical thing to do is when you get to that point in the before taxi checklist, bring those into the crossfeed and just leave your hand on it for 30 seconds. You can use your left hand, or work through the rest of the checklist while you've got your hand right here on the crossfeed, and then just flip it back up. That way you never forget to bring them out of crossfeed. Let's see here. And then finally we have the two mixture control levers, one for each engine. As you can see, they're located, they're the red ones located on the right side of the lever column there. Alright, so now let's go into a little bit more depth. Let's actually take a look and break down this schematic for the fuel system here. Alright, so starting out, we've got the fuel cells. We've got the left fuel cell and the right fuel cell, and that's just a fancy way of saying fuel tank. So we've got the left tank and the right tank. As we can see, we've got the scupper drains for both of them, and then we also have the fuel vent for both of them. Okay, so from the tank, we're gonna now, for this example, we're just gonna follow the left side, and the right side you could just imagine everything happening on the right side as well. But we'll just follow the left side, that way I don't have lines going all over and it gets confusing. So we're just gonna follow the left side, fuel from the left tank. Okay. So from the tank, the fuel is going to exit to our fuel selector valve, which is circled right there. That's our fuel selector valve. The position of the fuel selector valve in the cockpit determines the position of this valve, right? Remember, we have our cockpit controls, so that is going to determine the position of that fuel selector right there. If it's in the off, it'll simply stop the flow of fuel to the filter and the rest of the system. If it's in the on position, it'll allow fuel to come in through the top and into the filter, then onto the rest of the system. And again, with the crossfeed, here's where it kind of gets a little tricky. So let's say we have the left selector in crossfeed. Recall what we said earlier. If the left selector is in crossfeed, it's going to be getting the fuel from the right tank. So in order for that to happen, this is what's going to go on. So this fuel from the right tank, right, it's going to come down, cross over, and then the fuel selector will move out of the way to allow this fuel. It'll block the fuel from up here and allow the fuel from the right engine to come up and through and then onto the filter. Okay. Now normally if it's in the on position, it's blocking this crossfeed option, so it's just getting fuel straight from the left tank. So again, in the crossfeed, this valve right here is going to move, block this port up here, and allow the fuel from the right engine to come in and go into the left, or from the right tank into the left engine rather. Okay. Next, once it gets to this filter, it can go one of two ways. It can continue onto the system, or it can be drained out. Remember, we have those quick drains right out by the baggage door, so it's getting the fuel from this filter. Alrighty. Now, if it's going to continue through the system, on the left side, we see that it can go through to the heater. On the right side, there's no option for it to go to the heater. So that's something to note, is if we do have the heater on, it's using about a ½ gallon per hour, and it's taking it from the left fuel tank. Okay? So it's going to either go to the heater or continue on to the engine. Alright, so after the filter and sump, it's going to go through to the electric fuel pump. Then from there, the engine-driven fuel pump. One thing to note with the electric fuel pump, those should be on during takeoff and landing, just to provide extra backup in case for whatever reason the engine-driven fuel pump fails. And then it's also obviously needed for startup as well, because your engine's not running at that point. So after the engine-driven fuel pump, it's going to go to the fuel servo. Okay, so this is the fuel-to-air metering system for a fuel-injected system. So depending on the position of the pilot-controlled throttle and mixture control levers, this servo is going to regulate how much fuel gets mixed into the air that's going into the engine. So a good way to think about this is, if you're familiar with carbureted engines, this is like the carburetor of a fuel-injected system. And that's an easy way to think about it, and it's pretty accurate. So from the servo, it's going to go through to the fuel flow transducer. It's a really big word, but what that essentially means is that it's going to quantify the amount of fuel flowing through the line, and that's going to show up on our MFD in the form of our fuel flow displays. All right, so that's just the sensor that tells us how much fuel we're using. Okay. From the transducer, we're going to go to the flow divider, and I'll have a picture of this next slide, I believe. So this is commonly referred to as the spider by mechanics, because that's what it looks like. It's mounted on top of the engine, and the flow divider is spring loaded. So when there is fuel flow, it's going to depress that spring and allow fuel to flow evenly to all four of the nozzles. And then when there's no fuel flow, it's going to cut it off evenly. So you won't end up with one cylinder rather getting fuel while the other ones aren't getting fuel. So from the divider, the fuel is routed to the nozzles, and again, 4 nozzles for each cylinder because it's a fuel-injected system. Okay, and then from the nozzle, it's used for combustion to power the engine. So here's that fuel flow divider, and then the nozzle as well. So on the left side, you can see the divider, again called a spider, located on top of the engine, and that distributes the fuel evenly to the nozzles. And then on the right side, you can see that nozzle. Typically, they're made of brass, pretty simple construction, and they're usually tapered as well. So let's take a look at just a couple causes of trouble that we as pilots probably should be aware of. That way, if something does go wrong, we can speak semi-competently to a mechanic and have them fix the problem as quickly as possible. So if we have a rough running engine, the first place most mechanics will start after ruling out some sort of ignition problem, a fouled spark plug or something like that, is with the lines or the injector. Now, if there's some sort of debris clogging a line or the nozzle, the corresponding cylinder will be getting less fuel than the rest of the cylinders and could cause the engine to run rough. Right? So if it's not getting enough fuel, it's going to be running lean, and we know that a lean running cylinder is going to produce high exhaust gas temperatures. So that's going to be the indication for us in the cockpit is, hey, we're seeing that one of our cylinders has an abnormally high EGT. Well, it could potentially be due to a clogged fuel line or a fuel nozzle. And the second one would be, again, going back to that fuel servo, it's kind of like the carburetor of the fuel injected system. So if that thing is leaky, we could run into a scenario where it's leaking so much fuel into the lines that it would be impossible to shut down the engine by cutting the mixture off. Even with the mixture control lever in the cutoff, all the way down into the cutoff, there could be enough of a leak in that servo to where it's still combustible in the cylinder. So if we run into that, you'd have to find some other way to shut down the engine other than cutting off the mixture. So that 2 things to take a look out for, especially with the Seminole fuel system. Here are my sources: the Piper Seminole AFM, and then a really good article by Jacqueline Shipp for piperflyer.org, Understanding Your Lycoming Fuel Injection System, and then some Google images. That'll be it. Thank you.